Can you explain what is Batch Apex and how does it work?
Batch Apex in Salesforce is a feature that allows developers to process large sets of records asynchronously. It enables the processing of millions of records while complying with Salesforce's governor limits such as CPU time and heap size. Batch Apex jobs break down the data into manageable chunks called batches, which are processed separately. This helps in reducing the load on system resources and prevents hitting governor limits. Batch Apex jobs consist of three key components: the start method, the execute method, and the finish method. The start method is responsible for initializing the batch job and identifying the records to be processed. The execute method processes each batch of records, and the finish method is executed once all batches have been processed. Batch Apex is commonly used for data manipulation tasks such as data cleansing, data migration, and complex calculations. It allows developers to efficiently process large volumes of data without impacting system performance or running into governor limits. So, primarily, Batch Apex is a powerful tool for handling bulk data operations in Salesforce.
All right. Uh, Let us move on to the next question. What are future methods?
Future methods in Salesforce are a type of asynchronous Apex method that allows developers to perform long running operations in a separate thread independent of the current transaction. By marking a method with the add future annotation, Salesforce queues the method to be executed in the background at a later time. One of the key benefits of future methods is that they help avoid hitting governor limits such as CPU time or heap size, which could occur with long running operations performed synchronously. These methods are commonly used for tasks like making callouts to external services, processing large data sets, or performing operations that require considerable processing time. It's important to note that future methods have certain limitations. For example, they cannot return a value, except as objects as parameters if they are to be executed from triggers, or be called recursively. Additionally, future methods are subject to their own set of governor limits, such as a maximum of 50 queued or active future method calls per transaction.
Okay, moving on to the next question. What are recursive triggers?
Recursive triggers in Salesforce occur when the execution of a trigger on a particular object causes another trigger to fire, either on the same object or on a related object, leading to a loop of trigger execution. This can happen when the trigger's actions, such as updating records or performing other DML operations, cause the same trigger or another trigger to fire again. Recursive triggers can result in several challenges, including performance degradation, governor limit violations, and unexpected behavior in the application. For example, if triggers continue to fire repeatedly, it can consume excessive CPU time and lead to timeouts or even trigger execution limits being exceeded.
All right. Can you also talk about how to prevent recursive triggers?
To prevent recursive trigger issues, developers must implement mechanisms to control trigger execution. This often involves using static variables or flags to track whether the trigger has already been executed in the current transaction, thereby avoiding redundant trigger execution. Additionally, developers can utilize trigger context variables and recursion control patterns to ensure that triggers only execute when necessary and do not create infinite loops.
Okay, let us move on to the next question. Can you mention a few best practices you follow while writing Apex triggers?
There are quite a few best practices I follow while writing Apex triggers. I always use single responsibility principle, which means each trigger should have a single responsibility, such as handling the logic for a specific object or process and avoid creating monolithic triggers that perform multiple unrelated tasks. Secondly, I always prefer implementing trigger handler pattern to encapsulate trigger logic in separate classes. This helps in organizing code, promoting reusability, and simplifying unit testing. I also ensure that triggers are bulkified to handle operations on multiple records efficiently. I avoid using SOQL or DML statements inside loops as it can lead to hitting governor limits and poor performance. I also implement mechanisms to prevent trigger recursion and avoid infinite loops. I make sure to use try-catch blocks to catch and handle exceptions appropriately to properly handle exceptions and ensure that trigger operations do not fail silently. I also ensure to refrain from hard-coding record IDs or other static values within triggers. Instead, I use dynamic queries or custom settings to fetch IDs dynamically based on